Good morning friends, I Anupa Sudana and my mate Akila Barari from 4th year Biomedical Engineering, students of Kokaraju Rangaraju Institute of Engineering and Technology. Herein demonstrate our project titled ECG Monitoring System using LabView. As we all know, LabView is a flexible platform for graphical programming and hardware integration to design, measure and control systems. ECG, that is electrocardiogram, is an interpretation of electrical activity of heart. Frequency range of ECG is 0.01 to 300 Hz and amplitude range is 0.05 to 3 millivolts. In LabView, we open VIs, one for server and the other for client. These are the front panels of server and client. Coming to the server, here we take the ECG signal using a simulator wherein the data of a ECG is driven, and using the wavelet analysis we take up the QRS complex, we plot the data, process the data that is filtering and plot the peaks of the QRS complex. Using index arrays we define the RR interval through which we calculate the heart rate. This heart rate as a basis we calculate three different diseases, that is tachycardia, bradycardia and sinus arrhythmia. And apart from that, this heart rate is transferred from server to client using the UDP protocol, that is user datagram protocol. In this user datagram protocol, in the server part we open the UDP port, we initialize the port at first, write the UDP port either broadcast or writes to the specific host. Then we close the data. In this, the data is transferred in the form of strings. So we convert the heart rate that is in the numeric form to a string form. And we close the UDP port. This is the part of server. And coming to the part of client, this is your client block diagram wherein we open the UDP port, we initialize the same port number as that we have initialized in the server, then read the data from the port, reads the number of bytes received and then adds them to the one read in the previous iteration. We concatenate the data received and display it in the string indicator. If the UDP read times out, reset the error cluster so an error doesn't show, and the flattened string that is sent in the UDP server is unflattened in this client part, and the type order is defined as a little endian wherein it is the data is received from MSB to LSB and the value is displayed, and whose type order is DBL, that is double length of a long integer. And here we close the UDP port, then check for the errors. Coming to the front panel of the block diagram, this front panel is for the server part. We run the server part first and then the client part for the transfer of data. This is your simulated ECG signal that is obtained using the simulator of the ECG that is inbuilt in the LabView. Here in this project we use two basic toolkits, that is one is biomedical toolkit and the other is advanced signal processing toolkit of the LabView. These are the processing windows wherein we take up the wavelet analysis graphs and then square them and square root them. Finally we get the QRS complex wherein we plot the peaks. We plot the peaks and we calculate the distance between the peaks and find the RR interval and then calculate the heart rate. These are the signals wherein we can find the different diseases. And this is bradycardia, this is tachycardia and sinus arrhythmia. Bradycardia is the heart rate less than 60, tachycardia is heart rate greater than 100. So for showing the working of the server, we take the simulator and increase the heart rate somewhere around above 100 to get the tachycardia, I have taken it as heart rate 106 BPM. Okay, now run this part. See the server, it indicates the tachycardia. And now if we see the simulator and take the value of the heart rate below 60, that is around 50, okay, 50. Now run the server block diagram, then we get the signal to be bradycardia. That is, the simulated ECG signal that is obtained to the program is bradycardia. And now coming to the part of UDP. This is the remote host. This is the remote host. This is the local port, remote port, and the reception. That is the number of signals that the UDP have to take at each iteration. The data in the form of a string. We are converting the data into the nearest integer value and the decimal integer string that is sent using this server UDP protocol. And as usual, we convert this to a basic heart rate of about 72 to check the proper functioning. Then here it is. Run the server. Coming to client. This is a block diagram of client UDP protocol client side. Here, this is your front panel of the client, wherein we define the ports. The port should be as that we have defined it in the server side, and it displays the maximum bytes received or read. It indicates how many bytes we have read as of now. It gives the string value that is sent through the UDP, and the value is displayed. Here, this is your heart rate value 72. The value indicated here is also 72. Now let us check if it works for another value. We'll change the server value, that is the simulated ECG signal value, to around 87. The heart rate here we defined it as 87. Now we'll run the signal server, run the client. The server part heart rate is changed to 88, 87. Here the client part is also converted to. Now let us check if it works for 55. See, the simulated value is converted to. First we'll off the simulator, then check for 66 BPM. Now run the server. In the server part, we get the integer value as 66. Now coming to the client part, restart the client server. You'll find the value to be 66. And this transmission of heart rate from server to client, that is from one window to the other, or using the protocol from one system to the other, is the basic idea of our project. Thank you for watching.